Yeah, so as we have seen already what cellular systems are, we'll just take a quick recap of what it is and then move ahead with the topic. So we all know that a cellular system is nothing but a mobile communication device, we say, which is implemented in a space division multiplexing. Like different local areas are divided into different cells. Like each transmitter, typically a base station, that will cover a certain amount of area. That area is nothing but termed as cells, so that we can sort out problems area wise, like if there is any local interference in the channels or if it is working properly or not. So targeting the whole region becomes very difficult, to track down the problems. So what do? Entire region we divide it into small parts, small stations, where each transmitter is fitted, and such base stations are nothing but called as cells. Cell radii can vary from tens of meters in building and hundreds of meters in cities up to tens of kilometers in the countryside. So depending upon the range, depending upon the signal strength, and depending upon the complexity, you can define cell radii according to your convenience, according to what is needed at that moment of time. Whether it can be from few meters of a building to hundred of meters in cities, or it can also be countrywide. The shape of a cell are never perfect circles or hexagons. Now, the cell shapes cannot be perfect. Like before this thing, it is very important to know. I don't know if you have covered that or not, but there is a big question like why the shape of cells are always considered in hexagonal pattern and why not circle pattern. So let me show you an example for this. Yes, so as you can see in the figure, whenever we are trying to use circular shapes as a cell over here, the problem over here is very clear that there are few gaps. Okay, there are few problems. कि जो खाली spaces है, those are left. Like these areas, these regions are left to cover if you use a circular structure. So we basically use a hexagon cell. You can also use a triangle, you can also use a square, but the area covered by an hexagon is larger compared to any triangle or square. Hence, we use hexagonal patterns for the cell construction. So the shape of cells is basically what is preferred is nothing but hexagonal cells. It depends on the environments, on weather condition, and sometimes even on the system's load. Exactly कौन से type का cells लेना चाहिए, कौन सा type of cells use करना चाहिए, also depends on other factors like whether it is a building, whether we are covering mountain valleys as a scenic environment, or what weather conditions are there. So what type of cells will be suited? Because sometimes you have to cover larger areas, sometimes you have to cover smaller areas. But it is very obvious, I say quite obvious, that circular cells will not be used that much because it leaves a gaps in between, which means it leaves some areas to cover. Typical systems using this approach are mobile telecommunication systems, where a mobile base station within a cell around a base station communicate with this base station and vice versa. So if you can see that where the cellular system is are nothing but a mobile station, where you have seen that there are two different towers. Those are the base stations. So mobile station, when it is in one range, it communicates with that. Let me help you with an example in this as well. So let's say there are two towers. Okay, so I'll name this as tower A and let this be as tower B. So here we have, this is station A. Okay, and this is station B. So these stations have their own signals, okay, which are moving across. They have their own light, electronic signals which are moving around, which may be light or which may be heavy, is what I am trying to tell. So let's say we have a mobile device. Okay, there is a mobile device, or let's say a person is moving from station A to station B. So while moving, while traveling, now as you can see, ये मोबाइल फिलहाल स्टेशन ए के नजदीक है. So what it will do, it will just take all the signals available from station A, right? जो भी स्टेशन ए के यहाँ से सिग्नल्स अवेलेबल है, सॉरी, वो सारे सिग्नल्स ये कैच करेगा. Okay, it will catch all the signals which are available at station A. The moment it starts moving away from station A, yani somewhere when it is between station A and station B, so in that case what happens कि ये जो सिग्नल का स्ट्रेंथ है, यहाँ से जो सिग्नल का स्ट्रेंथ आ रहा है वो वीक होते जाता है. Again, similarly, when it is almost on the verge or say it reaches station B over here, then it picks up a frequency from station B. यानी स्टेशन बी का जो भी फ्रीक्वेंसीज रहेगा वो ये मोबाइल कैच करना शुरू कर देता है. So what I'm trying to tell over here is when the object or say when the mobile say the sender is between station A and station B, in that case both these stations का इक्वल रेडिएशंस और से इक्वल फ्रीक्वेंसीज होता है. सो दैट इज वाई सी समटाइम्स व्हेन वी आर ट्रैवलिंग, कभी कभी नेटवर्क क्लियर आता है, कभी कभी नेटवर्क बीच में गायब हो जाता है. वो गायब इसके लिए होता है क्योंकि हम रेंज से बाहर जाते हैं. सो व्हेन वी से कि हम रेंज से बाहर गए हैं, तो रेंज से बाहर जाना मतलब क्या कि जो बेस स्टेशन है हम उससे दूर जा रहे हैं. तो जितना नजदीक रहोगे उतना स्ट्रेंथन सिग्नल मिलेगा, जितना दूर जाओगे द सिग्नल विल बिकम वीक. सो व्हेन इट इज इन बिटवीन, तो इसका आधा सिग्नल ऐसा रिसीव करके इट ट्राइज टू मैनेज द कॉल्स. as soon as it moves forward towards station B, it will receive all the frequencies from station B and hence it is back in network. So इसमें बेसिकली बताने जैसा यही था कि जब आप बेस स्टेशन के आसपास होते हैं तो अपना नेटवर्क स्ट्रांग होता है. जब आप बेस स्टेशन से दूर चले जाते हैं तो आपका सिग्नल वीक होते जाता है. लेकिन वो सिग्नल वीक कब तक होता है, जब तक आप दूसरे स्टेशन के नजदीक ना पहुंचो तब तक. और जब आप एग्जैक्टली लाइक मिडल में होते हो तो आपको आधा आधा फ्रीक्वेंसीज आता है. इट इज नॉट लाइक ऑलवेज लाइक 50-50. इट मे हैपन दैट इससे दूर हो तो इसका थोड़ा कम सिग्नल आएगा, इसके नजदीक हो तो इसका ज्यादा सिग्नल आएगा एंड वाइस वर्सा. So what are the advantages of cellular systems with small cells? So we'll see right now. First is higher capacity. Higher capacity in the sense, as we say, it is space division multiplexing. Like based on area, we divide it into cells. It allows frequency reuse. यानी आप same frequency दो different cells में use कर सकते हैं. If one transmitter is far away from another, that is outside interference range, it allows to use the same frequencies. यानी अगर एक ट्रांसमीटर और दूसरा ट्रांसमीटर बहुत अलग अलग जगह पे है तो आप सेम फ्रीक्वेंसी अलग अलग बेस स्टेशन में यूज कर सकते हो. ये जो दूसरा फ्रीक्वेंसीज है उससे प्रॉब्लम नहीं होता है बिकॉज द स्टेशंस आर base stations are at different locations. Next is less transmission power. While power aspects are not a big problem for base stations, they are indeed problematic for mobile stations. A receiver far away from base station would need much more transmit power than the current few watts. तो obvious है कि less transmission power मतलब ये प्रॉब्लमैटिक सिर्फ मोबाइल स्टेशंस के लिए होता है. जैसे हमने अभी इसमें पेंट में देखा था कि अगर बेस स्टेशन और रिसीवर स्टेशन यानी जो टावर है वो और मोबाइल के बीच का डिस्टेंस ज्यादा है, देन द टावर हैज टू ट्रांसमिट फ्रीक्वेंसीज विद डबल पावर. यानी बहुत ज्यादा दम लगा के सिग्नल सेंड करना होगा सो दैट रिसीवर कैन रिसीव इट. अदरवाइज इट विल जस्ट ब्लॉक दैट फ्रीक्वेंसी या कभी कभी देखो ऐसा चैनल चला जाता है, नेटवर्क चला जाता है, वो इश्यूज आ सकते हैं. बट सेल्युलर सिस्टम्स में ऐसा नहीं होता है. सेल्युलर सिस्टम में द सिग्नल इज स्ट्रेंथेंड वेरी नाइसली. लोकल इंटरफेरेंस ओनली बिकॉज वी हैव डिवाइडेड इट इनटू लोकल एरियाज. तो अगर क्रॉस कनेक्शंस होता भी है तो विद इन लोकल एरियाज ही होता है. एज यू मस्ट हैव एक्सपीरियंस्ड मेनी टाइम्स दैट whenever you're trying to talking or calling someone, कभी कभी कनेक्शन ऐसा लगता है और दो तीन लोग ऑलरेडी बात कर रहे होते हैं and you can hear them. So that is called as cross connection or we say local interference. But local interference in the sense because you have been divided into a single cell, सो सिर्फ आपके एरिया के रिलेटेड क्रॉस कनेक्शंस लगने के चांसेस होते हैं, नॉट एंटायर सिटी और एंटायर कंट्री. नेक्स्ट इज रोबस्टनेस. रोबस्टनेस मतलब सेल्युलर सिस्टम्स आर डिसेंट्रलाइज्ड